Assalamualaikum warahmatullahi taala wabarakatuh dan selamat sejahtera. So we start our class. So today we need to understand the strain energy of the wire. So before we continue, so we have the wire here, and then we apply the force F here, and then what happened to the wire? The wire starts to extend. So E. L0 is the original length of the wire and A is the cross-sectional of the wire. And then from that we can get the stress. Stress is equal to the applied force F over the A cross-sectional area. And then strain is equal to the E extension of the wire over the L0. L0 is the original length of the wire. And then after that we can get the modulus Young. E is equal to the stress over the strain, or we can write as the stress F over A divided by the E over the L0. Okay, so then we have the graph here. So this case graph is the applied force against the extension of the wire, and then we have the directly proportional graph or the linear graph, and then here is the area under the graph. So area under the graph actually is the work done or the energy stored in the wire. Then from the graph, area under the graph we can find by half times the F force times the E extension. Then we can get the 1 over 2 Fe. So we get the work done. So actually the work done for the from the graph force against the extension actually is your strain potential energy. Then we can write the strain potential energy. The symbol is the U, the unit is joule. Therefore we have the U is equal to the 1 over 2 Fe. Okay, so we continue from the Young modulus. E is equal to the strain over the stress over the strain. Then we can get FL over the AE. Then we manipulate the equation. At last we have the F is equal to the E modulus Young. A cross-sectional of the wire. E is the extension of the wire over the L0. Then we have the half Fe. So we replace the F with here. Therefore we manipulate the equation, and then we have this equation 1 over 2 EA E power of 2 over the L0. Then at last we have this equation. U is E modulus Young. A cross-sectional area. E is the extension of the wire power of 2 over the 2 L0 original length. Okay. Then U also known as the energy stored inside the wire. So the energy stored inside the wire we can calculate by apply this equation, or we can use this equation 1 over 2 Fe power of 2. Okay, then hope for this part we understand the strain potential energy of the wire. So and then we go for this graph the stress over the strain. So we have this graph. Then area under the graph is 1 over 2 times stress times strain. Stress 1 over 2, area under the graph 1 over 2 times stress, and then time the strain. So stress is F over A, strain is E over L0, and then we can get manipulate to get this equation 1 over the A L0 1 over 2 Fe. 1 over 2 Fe actually is your energy stored from this equation. So the energy stored, or normally we can call as we know as a strain potential energy U. A L0 is your L0 height of the wire. A is the cross-sectional area. A times the L0 actually is the volume of the wire. So we can, from this we can write as a energy stored over the volume, or the strain potential energy U over the volume. Okay, then from the area under the graph, we know as the half times stress times strain. So half times stress times strain is equal to the energy stored over the volume. Then energy stored is your U. Actually, U is the strain potential energy over the volume. And then at the last, we can write as a, manipulate this equation, we can write as a energy stored U. The unit is a joule, time equals to the half times stress times strain times the volume. Volume in this case is your A L naught. For the stress is F over A, for the strain is E over the L naught. So this one is the another equation for the energy stored in the wire. Actually is equal to 1 over 2 times stress times strain times the volume. So hopefully we can understand how to find the strain potential energy inside the wire. For that, thank you.